Hey everybody, today we're going to be looking at area. More specifically, area in between two curves. Now, you may think you know a little bit about area, but really let's go over what you know. You know the area of a square, side squared, area of a rectangle, that's length times width. You know triangles, circles, you know all the formula stuff, but really, look out into the world. What looks like that in the world? Not much. You're going to find more shapes that look something like this. How would you find the area of that? Well, using calculus. Let's see what we want to find. Let's start a graph. How about we graph the 2 points, the two equations, x squared plus 2x plus 1 and negative x plus 8. Okay. Now we're trying to find this right here. So we'll use integration to find the area of this, because integration is basically the area under a curve. Well, we need to know our boundaries for integration, so this right here is about x equals 1.54. Okay, well, how are we going to find this? Let's think about what we know about area. We know that area is in 2 dimensions. That's why we have side times side, or we have length times width. It's why all you science people would know we always get units squared when we're finding the area of something. So what would be our 2 dimensions here? We can't really do length times width. It doesn't really work here. How about for the first dimension, we can have the integral. The integral dx from 0 to 1.54. Okay, but what is the integral? I want you to actually understand what it is. The integral is basically all the little tiny points in there going on towards infinity in between these 2 points, those values added together. It's kind of confusing, but some smart math people figured it out, so let's just go with it. So that's our first dimension. But what's our second dimension? Well, what if we can find height of this? Use that as our second dimension. Well, what would be the height of equations? Generally, when we're finding height, we know like height in between points, like on a triangle. If we know this is 3, 4 up here, and this is 3, 1, we know that the height right here would be 3. So we know how to find height in between points. It's just top minus bottom. So how would we do this with 2 graphs? Well, we can still do top minus bottom. The thing is, the height in between here is always going to be changing based on what points we have. And what changes based on the points? Well, another equation. So we can just get an equation of the height, which is why we do top minus bottom, or in this case, negative x plus 8 minus x squared plus 2x plus 1. Distribute the negative, we get negative x squared minus 3x plus 7. So, right here we have our 2 dimensions. Now let's just put them together. The integral from 0 to 1.54 of negative x squared minus 3x plus 7 dx. Do not forget the dx. And then we just do the simple calculus that we know. And it comes out to about 6. So it's really as simple as that to find area in between 2 curves. Well, I hope you'll join me in my next video where I'll be talking about volume. Volume gets a little bit more in depth than area. A little bit.